Alright, for the next problem, it's actually a relatively challenging problem. We're going to solve every single corral problem that has ever been written. There are n adjacent corrals that are W by L feet and a fence perimeter P. We want to find the max area. Or rather, we want to find what dimensions will give us the maximum area. This is going to really put your algebraic skills to the test, and it'll also test whether or not you understand how to do min and max problems. So, first off, we have all the variables defined, and I want to be crystal clear that W and L are variables, but N is a constant. N is a parameter that we set before we really start the problem. So we'll be playing around with it in our algebra, but we need to think of it as a constant, not a variable. So first we need a primary equation. Alright, our primary equation is regarding area. So we're going to have A equals, well, if we have n corrals and they're each W times L, then each area is WL and there are n of them, so NWL. N times W times L. Our secondary equation is going to have to do with the perimeter, because we have W and L. Remember, these are variables, this is a constant. W and L we need to link using a secondary equation. Now, this is a little trickier. You need to be able to abstract. If there are n corrals, how many W's am I going to have? Well, I'm going to have 2 W's for each corral. So 2NW is going to give me my width contribution. Now, as for length, consider what I have diagrammed here. Imagine that this is a 5th corral. Then if that's n equals 5, then I'm going to have 1, 2, 3, 4, 5, and a 6th one here, because there's one more length to close off the figure than you have corrals. So n plus 1 L, and that's going to give me my perimeter. Now here the choice for which variable to solve for is fairly arbitrary. I am going to try to solve for W because I noticed that I'm going to eventually divide by 2n, and if I have a 2n in the denominator, maybe that'll cancel with this. Who knows? We'll see. So I'm going to solve for W. So 2NW is equal to P minus n plus 1 L, and please don't distribute that. Resist the urge. So W is equal to P minus n plus 1 L over 2n. Now when I move this up into W, I'm going to get area equals n times L times P minus n plus 1 L over 2n. That cancellation that I talked about before, that I based my decision on, is actually going to come true. So now I just have L times all of this over 2. So let's distribute. Area is equal to P over 2 times L. P and 2 are constants, so I'm going to write them together. P over 2, and then L. Then n plus 1, again I said n is a constant, over 2 times L. So minus n plus 1 over 2 L squared. That's a quadratic. It's a quadratic that opens downwards. Namely, rewriting it more friendly, negative n plus 1 L squared. Don't square the n plus 1. All over 2 plus P over 2 L. And I don't really need to extend the fraction bar to the L squared. Just keep it clean. Now the L coordinate of the vertex is going to be negative b over over 2a. So that's negative p over 2 over 2 times negative n plus 1 over 2. Kind of writing that very small, so I hope everybody can see that. Well, the negatives are going to both cancel. The 2 in the bottom is going to cancel. So essentially we have p over 2 divided by n plus 1. The 2 in the denominator can be, of the p, can be moved down, so we get our final answer for L, at least, of p over 2 n plus 1. And this is a nice, compact answer. Now, finding W is slightly challenging. What we need to do is we need to plug this back into another equation to find W. Now, in most cases, I would tell you to find the equation that most directly solves for W, but that's going to give us some very complicated fractions. Instead, I'm looking at this one and I'm saying n plus 1, there'll be some cancellation. Maybe I can just work some algebra from there. So there, I do 2nw. I'm moving up so that I don't run out of room. 2nw plus L times, not L times, n plus 1 times. We're substituting L. P over 2 n plus 1. And that equals P. Well, there's the cancellation. So I have 2nw plus P over 2 is equal to P. So I'm going to subtract P over 2 to the other side. Now, something minus half of something is half of that something. So P minus P over 2 is going to give me P over 2. So 2nw is equal to P over 2. Now all I have to do is solve for W. W is equal to P over 2 divided by 2n, which is P over 4n. And L equals P over 2n plus 1, and W equals P over 4n. This will solve any Corral problem that you might chance yourself, or you might chance across in the notes or in the book.